A square sheet of paper ABCD is folded. That B falls on the M of midpoint of M of CD here. So let's first of all draw a square. So I'm drawing a square, and let's say this is a square piece of a paper. Mark the points, that is A, B, C, D. And there is a midpoint M of CD. So I can mark this is nothing but this is midpoint M of CD here. Let's say the length is DA equal to 2, AB is equal to 2A, and MD, as M is the midpoint, so DM I can take it as A and MC as A, and the BC is equal to 2A. So what you can do in such type of the questions, okay, just take a square piece of paper in your hand and just mark these points A, B, C, D the way I have marked, and try to coincide point B to M. Now when you join point B to the point M, you'll get a figure like this, which I'm going to draw it on the next part. So this is A, this is A, this is B, this is D, and this is C, and this is M here. So join point B and M. You do not need to join. You need to make sure that the point B coincides with that point M. And then you can observe the figure. Just take a piece of paper in your hand for better understanding here. Now, so if you look at here, it will looks like this. If I say this is the region, yellow region. So if I draw it now, the figure will be like this one. I can see not from here to here. I join from here to here. And the length of the crease. So this is the crease. And we can say like this and this. Okay. So this is point A dash. So this point A, it will be get shifted to A dash. I'm sure that you all can observe this if you take a piece of paper in your hand. Okay, this point will be get shifted to A dash. And this is the crease here. Alright. And I can say this is point, let me mark this as point equal to P. And assume that the length of CP, which is equal to X. So the length PQ, it is going to be PB, it is going to be equal to 2A minus X. Alright. And MP, it is also equal to 2A minus X. Because remember this M and this is nothing but also B dash. The point B I've coincided with this one. So this is also equal to 2A minus X. And the length MC is equal to A. And let me set the piece of the paper again. So this is my piece of paper. Not this one, just a minute. Okay. So this is a piece of paper, the yellow region, after folding. Now it says the crease will divide BC in the ratio. Now what is crease here? This length is nothing but that is my crease. So this divides the line BC in what ratio? So we need to find out what is the ratio of BP upon PC. Alright. So if you consider the triangle, this particular right angle triangle, so use the Pythagoras theorem. So if I use the Pythagoras theorem, I can say a square plus x square. It is equal to 2a minus x whole square. Now solve this. A square plus x square. It is equal to 4a square plus x square minus 4ax. So if I further simplify it, x square and x square will get cancelled, and I can say 3a square minus 4ax is equal to 0. From here you can take a as common, so I'll get that is 3a minus 4x is equal to nothing but that is 0. As a can't be 0, so which means 3a it is equal to 4x. And from here we can say that the value of a by x, which is equal to 4 by 3. So a by x is nothing but that is equal to 4:3. Now we need to find out the ratio of BP upon PC. So I'll say what is the length BP upon PC. So BP is equal to 2A minus x, and CP is equal to nothing but that is x. So that will be equal to 2A by x minus 1. And the value of A by x is equal to 4 by 3. So you can substitute it here. That is 2 into 4 by 3 minus 1. So 8 by 3 minus 1, it will be equal to 5 by 3. So this is the correct answer. So the correct answer for this question is 5 by 3, which is option number B. So I hope that now this question is also clear to all of you. Thank you.